Hey guys, welcome back to another episode of the Barnabas Rover and the light sensor. So today what I want to do is I want to go a little bit deeper into the light sensor, or also known as the photoresistor. So if you look at the whiteboard here, we have PR, which is right next to this resistor right here, which is the photoresistor. And we found out that whenever we shine a light on the photoresistor, the resistor gets smaller. And whenever we made the resistor dark, or we blocked it, the resistor would get larger. And we use that coupled with this other resistor up here, this 10 kilo ohm resistor, to create what we called a voltage divider. And what that allowed us to do is move this spot right here, which is connected to A0 on our Uno. So let me draw that. This A0 is on the Uno. It would move A0 up and down. So whenever the photoresistor got big, A0 would go up, kind of like an elevator going all the way up to the top floor of the voltage. And whenever the photoresistor got smaller, it would bring A0 down. And that was how we were able to tell, is it very light or is it very dark? Because the photoresistor size would change depending on whether it's light or dark. All right, and then using that, we were able to code our robot to, I have it plugged in right here with the code on it, that whenever it was dark, so right now it's not super dark, but the lamp I have here is not on. So when the lamp is off, it would just do nothing. But when the lamp turned on, this photoresistor would become small and then it would start moving. So let me turn the light on. You can look at the top right corner there. There. And when I turn it off, the light stops. The car stops. On, off. Okay. So that's just a review from last time. So the first step I want to do today is I want to simplify our wiring, okay? So the way we're going to do that is this. We look at our drawing, we say, you know what? We have this 10 kilo ohm resistor here, and we're using that to be part of our voltage divider. So that works. But what if I said I want to remove this? I don't want that anymore. So what if I did this? Well, you could do that, but my circuit's not going to work anymore because I need a voltage divider to get this elevator thing to work, right? So what we want to do is activate another resistor that is actually inside the Uno. Okay? There's another resistor inside the Uno that is internally connected to 5E. So if you do that, you still have your voltage divider. The nice thing is we don't have to put an external 10K resistor. Now, what is the value of this resistor in here? Is it 10 kilo ohm as well? The answer is it's not. It's not 10 kilo ohms. It's actually something else. So why is that important? Well, our elevator A0 goes up and down depending on the size of the photoresistor and also the size of this resistor up here. So if this resistor changes, the A0 values of bright and dark will also change too. So we're going to have to kind of deal with that as well. Okay, so let's go ahead and make some changes first to the wiring to match what I have here, and then we'll have to change the code too. So let's take a closer look here. All right, here's my breadboard here. All right, so if we look at, all we have to do really is just take out the 10K resistor because the photoresistor connection is the same. So all I do is locate my 10K resistor, which is right here, that I'm pointing to with my finger, and I just pull it out, and we're done. That was super easy. All right, so wiring wise, we are done. Then let's go to our code Okay. And what we need to do is we need to activate that resistor inside there. And before I almost forgot, before I do that, this resistor that's inside is actually called a pull-up resistor. We call it the pull-up resistor because it's pulling up voltage from here, pulling up to the 5V. So that's why we call it a pull-up resistor. And it's inside the Uno because what we're doing here is a very common thing. And so the designers of the Arduino said, you know what? Let's put in a resistor inside the Uno that can be used as a pull-up resistor so that will save people like you and me time and also space when they do wiring, because they can just use the pull-up resistor internally on the Uno. So that's a nice little bonus tool for us. Okay, let's go back, and now that we know it's a pull-up resistor, let's activate it. All right. So we're gonna set up the pin mode. So before we didn't have to do anything with the A0 pin, but now since we're using the pull-up resistor, we have to say pin mode A0, comma input pull-up. There. Okay, so that command says I want to use the input pull-up. And if you look at line 41, the button pin also uses input pull-up. So if you go back and look at the button video, you'll see that we also did the same thing where we remove the extra resistor by using the internal pull-up resistor. Okay, cool. I'll put a comment here. Photoresistor pin. Okay, the other thing I said, remember, is that the internal pull-up resistor is not 10K, so we have to redo these values here. So right now, or before, when I used 10K, super bright was 38, light on was 102, and so forth. Okay, so let's go ahead and redo those numbers before we keep going. Okay, I'm gonna comment out this movement code because I don't want my robot moving around when I'm doing this. Okay, all right, so let's connect in. Okay, all right, let's upload. Okay, cool. And let's look at the serial monitor. All right, so right now I have the light off. It is 64, right? 64. And light on, I'm going to turn it on, is 42. 64, light off, light on, 42. Okay, let's go ahead and write that down. So going back to my notes up here, light on is 42, light off is 64. Is that what it was? I think so. Yeah, that's right. Okay. All right, and then let's go full darkness. Let's see what full darkness is. So that's me just covering the entire photoresistor with my finger here. What's it say? 265. I'm gonna say 260. Just an estimate's good enough. And then super bright. That's tested using like phone here. Super bright. Right on top of the photoresistor. What do I have? About 20 or 19. Okay, it used to be 38. All right. So the first challenge is find out A0 levels using input pull-up resistor. Cool. And then once we do that, let's update the code so that the car moves when the light is on and stops when the light is off. Okay, and I'm gonna just delete these for now so we don't get confused here. All right. So when the light is on, we want it to turn on. We want it to move. So going back here, I'm gonna bring back my motion code, and I'll write a comment. If light is on, then do that. If light is off, then do that. Okay, so the light is on whenever A0, I think, is less than what number? When it's less than, I'm gonna say like 45. So it's less than 45, then the light is on. I think that should be a good number. So I'm gonna do 45. And I'm gonna say if it's greater than 45, the light is off. Okay, because as it gets darker, the A0 is gonna get bigger. Let's see how this works. I'm gonna upload. Cool. Okay. Let me turn on my light. And it seems like it's working. Okay. So my code's working now using my input pull-ups. Cool. Let me disconnect that. The next thing I want to do, I want to add a second photoresistor. Okay. Now the reason that we want to do that is we eventually want to be able to control the car to go left or right using the photoresistors. All right, so I'm going to add a second photoresistor, and the way I'm going to do that is just say, okay, drawing PR2, okay. One side is going to connect to 0 volts or GND, so same as the other photoresistor, and the other side is going to be connected to A1. And let me make some room here. This is Arduino. A1, which is another analog input. Okay. And then we also have, we're going to use that internal pull-up resistor to 5V. Okay. So we're not going to add another pull-up resistor, or we're not going to add an external one, but we're also going to use the internal pull-up resistor. Same situation for the A0 one. Okay, so let's go ahead and make that connection. You know, we have my second photoresistor, and one side is going to connect to A1, which I'll do in a second. Let's first do the other side connecting to 0 volts or GND. So I'm going to find my GND row here. And then the other side, I'm going to just make a new row over there. And then that row is going to be connected to, I'm going to use a yellow wire right here. I'll give you a bigger view if you would like to see. Okay. So this is my photoresistor. This is my wire going into that new row up here, and that goes to A1. There we go. A1. So now you see that if we use the internal wires or internal pull-up resistors, wiring of the photoresistor is super easy because we are already done. Okay. And I want you to notice I got one photoresistor on the left side and the other photoresistor on the right side. You kind of want to keep them separated because what we're going to do eventually is going to shine light on either one, and we want to be able to kind of tell it to go either right or left. Okay, so if you put the photoresistors right next to each other, it won't be able to tell if you're trying to go left or right. All right, so we are done with the wiring. Let's go to the code. Let's add in the code similar to before. Pin mode A1 input pull up. Okay. And then let's see what the values are for find out A1 levels using input pull up. There we go. Sorry about that. Here we are, pull up resistor. I realized it wasn't zoomed in there, so this was the line I just wrote, pin mode A1 input pull up, okay? And then let's find out the A1 levels, because maybe they're exactly the same as the A0 levels, but you never know, right? It's better safe than sorry. Let's double check. So I'm going to go here, and instead of printing analog read A0, I'm going to do analog read A1. And I'm also going to comment out my movement code. All right. Cool. So now let's copy this, because these are the 4 levels I want, except I don't know if these numbers will be the same, so I'm going to delete those out. All right, so now this is A1. Okay, so when it's not on, it's like 52. So when the light is off, it's like 52. So you can see it's actually a little bit different. Okay. Now if I turn the light on, let's see what it becomes. Becomes 28. So light on becomes 28. You see it's a little bit different. And then let's do super bright. Super bright with my phone. It's like 25 or something like that. So that's similar. And then let's see what full darkness is. So cover it. It's like 176. I'm going to say 175. 175. Okay, so if you look at this, our numbers are not super different, but kind of different. I mean, it's still the same concept as the darker it gets, the number gets higher. So that's the same. But you see the light on and light off are slightly different, and also full darkness, it's slightly different. Now, the reason that may be the case is that these photoresistors are not exactly the same, right? So if they were exactly the same, like they behave the exact same way, you would get the exact same numbers. But because they don't, because when they make these photoresistors, they might be a little bit different, or you might even have 2 photoresistors that have slightly different specifications. You will get different numbers. So it's important that you find out the levels for your resistors and not just copy mine, because again, yours will be a little bit different. Okay. All right. So now that I know that, let's have some fun here. All right. So let's say, what if I wanted to make it so that whenever the A1 turns on, the left wheel goes, and whenever the A0 turns on, the right wheel goes. I think we could do that, not too hard. And if we do that, I could kind of guide my robot to follow the light, right? So let's try. I'm gonna make some comments. If the A0 light is on, turn on or move the left wheel forward. If the A1 light is on, move the, oh, you know what? I messed up, right? This one is A1 for me. So if the A1 is on, move the left wheel. Okay, if the A1 light is on, move the left wheel. If the A0 light is on, move the right wheel forward. Okay, so now I have my comments. I know what the plan is. So let's write the code for the A1. So if analog read A1 is less than some number, then I want to move the wheel forward, else stop the wheel. Stop the left wheel. Just to be specific, right? We're talking about the left wheel. Okay. So when does the A1, for me, when the light is on, what value is A1? So A1 is 28. Okay. So 28 or lower is when the light is on. So I'm going to say less than 30. Give it a little margin there. So if analog A1 is less than 30, then move the left wheel forward. Let's see, what do I have for left wheel? I wonder if you know what? I'll just use turn left. So I'll kind of have it turn left. So this already has a delay in there and then a stop in there. Okay, so I don't have to explicitly tell it to stop either, because it's already inside the turn left. So it's gonna, like, when this light is on, it's gonna turn left and then stop. Okay. All right, let's do that. And then I'm just gonna leave this blank for now. And then if analog read A0 is less than some number, then I'm going to turn right. Else I'll just leave that blank for now too, just like the top one. All right. Okay. So let's figure out for A0, when the light is on, what is A0? A0 light's on at 42. So I'm going to say less than 45. Okay. Let's see how this works. Now, I'm going to try using my cell phone and kind of guiding it a little bit, and let's see if I can make it follow my light a little bit. Okay, let's see. Huh. It's constantly so it keeps on turning this way. Why is that? Huh, but I got to go that way too. So I'm playing with it right now to kind of see. Okay, it's kind of working. And then if I go from this side, it goes, the other one turns on. Okay. So the first thing is, I want to make sure I have this, I think I have my directions messed up, because if I turn on this light, I want this wheel to move, so it's actually turn right. Right? Yeah. So I have it reversed. This should be turn right, and this should be turn left. Okay, let's try that. Okay, I'm going to disconnect this and use my battery pack here. Okay, so I'm going to turn on my light and try to shine on this one right here, so it should turn this way. Okay, cool. Actually, yeah, that's what I want. Is I want it to turn that way. And then when I shine this one, it turns that way. When I shine that one, it turns that way. Okay, so it's kind of working there. Now, what if I want it? I think it's turning a little bit too much, like more than I like. So I'm gonna say, instead of turn 800, let's say like turn 200. I'm gonna keep the 800 because I might want that later. So I'm gonna change these for 200 for now, and then turn right. I might want that. I'm gonna change that to 200 for now. Okay, so that way it'll just kind of be more of a zigzag thing rather than move so much. Okay, let's try it now. There. So it's like I'm pushing it around but using a light. Okay, so that's working pretty well, I would say. So challenge 4, move the car, or I guess you could say it like this: push the car around left, right using a flashlight. So when you shine it on this side, it should push it this way. You shine it on this side, it should push it that way. Kind of exactly what I have here. Now, the next thing is number 5, and this will be maybe another video, is what if we could make it so that it follows the light, but when it doesn't see any light, it just goes forward. Okay? So the way it should go like this. Challenge 5 is car goes straight all the time, but when it sees light on the left, it turns slightly to the left. When it sees light on the right, it turns slightly to the right. So the car would just be going straight, right? And as it's going straight, if you shine light on the right side, it kind of veers a little bit and goes that toward the light. And then it'll go straight if the light goes away. If you shine the light over here while it's going straight, it'll kind of veer left. So that way you'll have this kind of car that's moving straight, that's following the light. Okay, so that's challenge number 5. No worries if you don't get there. I'll probably make another video showing how to do that as well. All right, that's all I got for you on this video. Have fun with that. Look forward to seeing how you guys do.